Welcome to this session. Welcome to the School of Engineering and Materials Science at Queen Mary University of London, and welcome to the Biomedical Engineering Open Day. This is the virtual open day online, so we hope to cover various aspects of the biomedical engineering program, your life as a student here at Queen Mary and the School of Engineering and Materials Science, and the various aspects of the next few years that you will experience as a student. Let me introduce myself first. So I'm Hussein Haydari, a lecturer in biomedical engineering. I specialize in 3D printing and additive manufacturing for healthcare applications. I received my PhD from Berkeley in the year 2020, and I've joined Queen Mary, been here for the past 2 years. Since 2021, late 2021. If you have any questions regarding the material that we covered during this session, or any other questions that we haven't covered, please reach us at either my email here, h.haydari@qmul.ac.uk, or you can find all staff member profiles under this website, sems.qmul.ac.uk. And if there's a particular area of research that interests you, for example, here, this page is going to take you to my research, and you'll be able to identify other areas of research as well. And if you have any questions, please reach out via this email, and I would be happy to help you find those answers. I'm going to explain a little bit of what I do and give you a taste of what we do in the biomedical engineering program in terms of research, which is hopefully going to drive you to some exciting projects and basically building up towards those in these next few years of your studies. So my area of expertise is 3D printing, and 3D printers have been around for a while. They were used mostly in the many years since 2010-15 by hobbyists to make these gadgets, or by artists and designers to make these fancy prototypes, but it soon became an engineering tool, and it actually has grown so much that final production is now possible with these machines. So a lot of these Formula One cars racing today are using hundreds of pieces off of a 3D printer. As a matter of fact, it's reached into many other industries as well, including healthcare and biomedical devices. So this is where my research focuses on. It focuses on manufacturing human tissues, so artificial replicas of our biological tissues, be that a full-size organ like a lung or a model of a human heart, or small chunks of tissue for biological studies. I'll explain a bit more in a minute, but the idea is to sort of end that long list of patients waiting for an organ transplant. Hopefully, at some point, we will have unlimited access to human organs that are printed and manufactured in the lab. And the idea is that these will be like spare parts in a vehicle, where you could swap your defected organ or the dysfunctional organ with a brand new one that functions perfectly. And so to get there is a long path, but we've already gone pretty far from where we started. This is a model of a human lung that has all those tiny blood vessels inside it, and if you put those blood vessels next to each other, it would form a road that spans all the way from the east to the west of the United States, which is a huge amount of blood vessels that run inside this replica. This is a sort of research that we conduct, is to be able to produce models of human tissues, human organs, to understand the biology behind it. I'll explain a bit more about the grander vision, but this was just an introduction to what I do. Queen Mary University of London has a history of excellence in biomedical engineering. We started as the very first medical college that taught medicine. It's pretty interesting. I'm not sure if a lot of you actually knew about this. At the moment, we have over 25,000 students. About 92% of those students are studying in full-time mode. We have a 68% undergraduate student body, and about 25% of our students are international. We have a very good balance of females and males present in the student body, about 55 to 45, which we're really happy with. And we continue to lead in many areas of biomedical engineering research. We have actually established as the first aeronautical engineering department to teach aeronautics, also the first to teach materials science. And now, after many years of its establishment 50 years ago, we still are one of the best in the country. So what you see here is the work of Professor Karin Hing and Liz Tanner on bone graft substitutes that are now used in hundreds of thousands of patients. And you can see the 50 years of engineering innovation stamp that has been marking this important and significant contribution of Karen. And many of our academics are leaders in these various fields in biomedical engineering. And that's why we have become top in our class. We are the second in the entire research framework for the UK when it comes to research excellence in engineering. And we are also the top UK university in social mobility. And this means that we have had the most number of students going from free meals to becoming the top 10% of earners in their society. We are part of the prestigious Russell Group, which is research-intensive universities in the UK. And we continue to attract a lot of funding in research. So we have a strong focus on research. And when it comes to the school, we have 1,500 undergraduate students that represent 70 different nationalities. And we are happy that within the School of Engineering and Materials Science, we have a 26% of students that are female, which is much higher than the 16% national average. And this number is also improving still this year and the coming year based on our stats. And we are a very broad research institute in the sense that we actually have 100 academics representing different areas of engineering research and about 20 in biomedical engineering. This is the stellar faculty that I'm talking about, who cover a wide range of areas, all the way from understanding molecules to full-size organs and tissues, and that's what you will be having access to, a broad range of expertise, and you can choose which area to focus on, whether it's understanding the physics behind these materials, whether it's innovating and designing new materials, or actually designing and developing devices that are going to be used in the human body then to assist surgeons and general practitioners, or whether it's the robotics aspects of biomedical engineering that interests you, or maybe it's the computational, the machine learning and the AI behind developing new systems that replicate the human body and sort of understanding the workings of our organs in a more accurate fashion, and trying to predict those procedures that happen in the surgical theatre and elsewhere in our healthcare system. And this is really, if I were to ask you what device or implant sort of brings you to biomedical engineering, or what sort of memory can you recall from an exposure to biomedical engineering innovations, you'll probably name one of these: a pacemaker, a stent, maybe a hip implant, maybe a blood pressure monitor. It can be a device, or it can be an implant, or it can be an imaging tool. it can be a variety of things that helps the healthcare system and healthcare in its entirety to work much better. And so this is the broad map of biomedical engineering, all the way from discovering new materials, understanding how cells interact with these materials, putting these cells and materials into a tiny chip or a small volume to study and monitor these various aspects of our biology and disease progression and therapeutic efficacy, and then using all of that knowledge to produce large organs and tissue replicas. So it goes all the way from the molecular scale to the organ scale. And behind all of this is computational design, computational simulation of these events. And you can find a detailed map of what we study in the school and the biomedical engineering program on the website for the Bioengineering Institute, and you can learn more about these different areas of experimentation and research, and you can reach out to those researchers and academics whose work is of interest to you. Basically, as a biomedical engineer, what do you do? What is your focus going to be? Well, as I mentioned, you're going to be designing systems that are used in healthcare. These can be implants. It can be an intraocular implant in the eye. It can be an implant that goes in your ear. It can be a bone mimic material that goes in your skeletal structure, or it can be soft tissue that replaces a part of your kidney or liver or heart. And it can also be a device, not an implant, but a device that is there to assist the function of that organ or tissue that you're trying to repair. Or it can be a device that's outside of the body, helping the clinicians to understand what's happening inside your body. It can be a variety of things. And typically, this is why we're very much interested in our jobs, is that it's very rewarding because you're saving lives, because you're helping professionals save lives, and not just one professional, but you're basically working at a global scale. If you innovate on a certain area, this will actually then spread across to multiple continents, not just the UK, and become part of the practice everywhere. And you typically have higher incomes and higher starting salaries as biomedical engineers, typically 20% on average. And that's because there's a huge need in this area. There's a huge potential that we are just starting to address. And because of this huge impact, it's very much rewarding. And typically, whether it's in your future career as an employee in a company that does biomedical devices, or during the 3 years of your studies as an undergraduate student, you are going to go through this cycle of identifying a medical problem, designing an experiment, a tool to actually solve that problem, developing that tool and optimizing it, and then basically once you've validated that it works very well with the human body, with that certain problem that you're trying to address, you launch it as a solution. And this could be a startup company that you launch, or it could be a device or tool that other companies acquire. So these are examples. This is a bone graft substitute material invented at our Institute for Bioengineering by Karen Hing. This was a product of undergraduate research and postgraduate research, postdocs, PhDs, masters, and undergraduate students working together to develop a substitute that could actually be implanted inside a broken bone to basically help it heal. And this company was acquired by Baxter for £220 million and is now very successful with over 50 employees. This toothpaste that is designed to solve hypersensitivity of teeth and reduce it to some extent is also another company out of a collaborative work between the Institute of Dentistry and the School of Engineering and Material Science. And it's not an implant, it's not a medical device, but it's a material that's used very often as a daily a consumption material that's in very close contact to the individual, and has a broad impact on their dental health. Again, the innovation here is the biomolecular design of this chemical and testing it with tissues in the lab to understand its performance, and now it's launched as a company. Another example is my research, as I mentioned earlier, producing 3D printers that are able to manufacture living structures that are embedded with cells. So what you see here is a model of a human lung alveoli, and it's beating. It's basically introducing the air through the sac inside, and then you have blood flowing from one inlet to the outlet. And as it circulates, the oxygen is giving the oxygen content to replenish the blood's depletion of oxygen, and then basically bring it back to an oxygen-rich blood that can then be pumped by the heart to various organs. And this company was also acquired for about 400 million by 3D Systems. So these are all examples of practical research that has made its way to industry and to touch people or researchers or scientists' lives and research in these areas. We weren't the first, but we were one of the first programs to be established in the UK for biomedical engineering back 23 years ago. The program is accredited by IMechE, the Institute of Mechanical Engineers, I believe also by the Institute of Materials, Minerals and Mining. It's a very well-known program. All of our colleagues at Cambridge, Oxford, Imperial, UCL are very fond of our students. The ones who graduate from Queen Mary are very well equipped with the tools that are needed, and this goes beyond academic research. It goes to GSK and Baxter and these large industries who have received year after year students and graduates from our program and are very happy and eager to recruit more and more as they see the level of knowledge and experience in these students. But let's get to your life as a student. You will spend a lot of your time in labs and hands-on sessions because we value that hands-on physical experience a lot. We will have practical labs. For many hours during the week, we will have problem-solving classes and lectures, also filling a major portion of your schedule. But then we will have other extracurricular activities, such as union activities and competitions, and of course, student support. And for student support, we have various schemes that I'm going to explain in a bit, but we encourage you to be part of students' union and the groups and cohort programs, including competitions in biomedical engineering across the country that will give you a good idea of what your future job is going to look like, but also exposure to some brilliant team making and collaboration with friends and colleagues in different areas. And the experience of having a team to compete in a competition or to participate in a conference or seminar is one that you would really remember every minute of it. So this is sort of what happens in a typical year one module that you are taught. So this is, for example, a class in materials engineering, which I teach. So you learn the basics of polymers, okay, polymerization, how do we produce plastic parts, okay, what's the chemistry behind it. You understand the mechanics of plastics, how they perform in the macroscopic scale, so you're understanding the connection of the sort of chemistry and the mechanics. And then you take that knowledge a few steps further. Now, finding out what's special about these materials that are used in healthcare systems, in an aligner, in a stent, in a heart valve, okay? And then you are able to use that knowledge that you've gained in year one to better understand the function and the material selection behind these different products. And then using this knowledge, you would further implement it in your third year modules to build and experiment. And here you get to learn all those practical tools and manufacturing systems and testing systems, and to basically develop your own devices. And this will be very helpful for your project. So in year 3, you will undertake a design project in biomedical engineering. And these are a couple of those examples, but just a few examples, not all, but they actually highlight the variety of topics that you could actually be working on. It could be all the way from studying cells, biomaterial performance, optimizing biomaterials, designing new biomaterials, or it could be working on, macroscopic gates and understanding robotics and exoskeletal research for human augmentation robotics, or robots used in surgery. It can be all the way from, implants that are used as bone implants or intraocular implants in your eye to a device like a pacemaker that you're trying to make it more efficient. So the choice is pretty wide, but you'll be able to designate what your interests are and choose a topic that interests you the most. Now, year 4 gets you a few steps closer. You're then able to actually either do this abroad, do this inside the UK, do it in an academic institution or in an industry to get a few steps closer to your future jobs. You can decide what that is that interests you, whether it's being part of that healthcare industry or actually being part of an academic research lab. And you can go a little bit thorougher and conduct the research and experimentation in a deeper level than what you did in the third year project. And to support you are all these variety of courses and modules that are optional that you're able to take and choose depending on what project and research interests you the most. And of course, the lab facilities, the workshops, the various labs for manufacturing, for studying tissues and cells, for understanding human macroscopic motion and dynamics, or to study microscopic structure of materials. And all of these, as well as the mechanical design workshop and the makerspace, will be at your disposal to use throughout the program and also the third and fourth year projects. We value the group and teamwork aspect a lot. We don't want to have it solely based on individual exams. So we have a lot of the elements of your examination and teaching are as a team. So that's why our classrooms, a lot of them are arranged in this sort of a team style sort of teaching setup. And we still have virtual tools to help you, assist you in understanding more of what happens in these research labs in a virtual setup. And then we have events and pathways to support you throughout the program. Of course, the Welcome Week event and the tutorials that you receive with your tutors, but also the PASS scheme, which is the peer assisted study scheme. Maybe you're stronger in one area and not as strong in another area. This gives you the opportunity to teach your peers or learn from them. And then we have teaching assistants and demonstrators throughout the modules and the years to actually help you, support you in learning those various skills and content. Then we have workshops that go beyond the research and scientific content, but also to help you with your writing skills, with your presentation and communication skills. And this is really important because these become a core component of your future growth in your future careers. to be able to, as an engineer, biomedical engineer, communicate your ideas, your designs to others in that space. And a very interesting opportunity is the Industrial Liaison Forum, and that allows you to be part of maybe your first conference, your first networking event, where we have hundreds of representatives from different companies coming to our campus, and you will be able to interact with them, to present your research to them, and maybe find your future opportunity here. And so in terms of your future careers, now that we're getting to the end of the presentation, we have numerous paths as a biomedical engineer. It can be joining industry, whether it's a small startup company or a large pharma company. You could go to the clinical route and join a hospital to help them with instrumentation and new devices and implementing those. You could join research facilities or academic research labs to do a PhD, a master's, or continue on just as a researcher. You may be interested in teaching at different levels, and you'll be able to do so in your area of expertise. And then there are government regulatory agencies. You could be part of the government deciding which device to use in a patient, or the high-level policy makers in NHS. You could then maybe focus on public health policy, and based on your knowledge of devices and implants, you would be a huge asset to the government in determining their future steps. And these are just a few of our graduates in the past few years. Not much time to compose this list, but you can see that they've ended up in various work settings, whether it's a hospital, an NHS program, or it's a PhD program and MSc program, or if it's actually joining a large company such as Medtronic or Matt Ortho, and becoming an engineer within that setup. And so really opportunities are endless, and we're here to make sure that you find your future path in the huge space of biomedical and healthcare engineering innovations. And with that, I'd like to conclude and leave the floor open for any questions that you may have for me. And this is the last slide. So please, if you have any questions, use the Q&A to actually type your questions, and I will be able to see your questions and respond as I see them. Thank you very much. So again, if you have any questions, please use the Q&A tab to post your questions, and I will be able to respond to your questions. Okay, so we have a few questions here. So one question is, during the duration of the course, do you have the opportunity to work in a hospital clinical setting? Absolutely. So summers are a great time for you to apply for short internships and to basically gain that experience of working in an area that benefits from your knowledge. And then as you do this, as you participate in such placements and internships, the next year when you come back to school, you will have a very good idea of what interests you more, and then you could choose your modules and courses to actually push you a few steps further in that area, and so you can gradually become an expert in that space. So we've had students who, for example, were interested in cardiovascular medicine, and they studied the first year module, the second year modules, and then on the second summer they went out to do an internship in a cardiovascular device company. We've had some who've done that in a hospital, and then they come back with a practical knowledge and idea of what's wrong there, and then, okay, I want to do a research project focusing on heart valve. And so that was what they did. And so this builds up your resume towards that ideal future role, and we absolutely encourage that. Okay, another question is, what kind of projects have you seen in the course? So a few projects that I've supervised, for example, one has been designing a valve for hydrocephalus shunt. So this is a brain shunt that is used to relieve the brain of the buildup of cerebrospinal fluid. And so the idea was to 3D print these shunts, these brain shunts, and to optimize the geometry and the material for the certain tissue sites that this was going to be implanted in. Another project, for example, and I'm talking about projects that I have done, and again, we have loads going on in robotics and electronics, biomedical electronics, or in computational. For example, from computation, a colleague of mine, Caroline Ronnie, she actually focuses on modeling the heart to understand diseased hearts. Why do they not perform as well? And so students have been looking at various geometries of hearts of the patients and understanding the flow, the fluidics inside the heart, and to figure out what the solution is. Another question is, if I refer to the course bioengineering in my personal statement, what effect will this have? Well, it's fine. The program is biomedical engineering. Please use the term biomedical engineering. But if you use bioengineering, we know these two are, in our case, synonymous. The Institute of Bioengineering, the Institute of Bioengineering is the host or the home for this biomedical engineering program. And so that's why we actually, yeah. So that's why it's fine to use both of those. Okay, so let's go to the next question. Do you recognize French qualifications? I'm not sure how this works with, we definitely do, but what qualifications and what equivalencies, you have to check the international qualifications page and see in terms of I personally am from Iran, for example, and for sure I had to convert my grades and they were accepted. Every country's qualifications should be accepted, but you've got to look into what those are, specifically with the A-level requirements. How do those convert? Do we have the possibility of learning more about the organ-on-chip technology? Absolutely. So a large set of research projects are designed on organ-on-chip, which is that chip that hosts the cells and tissues. And the idea is to study these tissues at a microscopic scale and understand the biology. We actually have a partnership with Emulate, which is one of the largest 3D organ chip companies based in the US. And we actually have an Emulate Center. That's why a lot of our research projects are based on this topic. You would absolutely have one. There's actually one happening right now in the third year project, which is understanding, I believe, cardiac dysfunction using a cardiac heart model on a chip. Okay. What are the idea subjects that require, please? Okay, so biology is not needed. You need to have 2 of the 3, maths, physics, chemistry. Biology is not needed. The third one can be anything else. Okay, so 2 of the 3. Biology is not needed. Can you tell us about the application process, how students filtered through and are given offers? Yes, so we look at the minimum requirements, but if there's always competition, we look at the best candidates. So we look at your statements, which are really important. We look at your past experiences, and grades are very important. So indeed, the predicted grades are key in this respect. What is the selection criterion? As I mentioned, there is no interview, but there are criteria based on your grades based on the statements that you write. Every bit of that application does matter. And so please pay attention to all aspects of it. What is a typical offer? Thanks, please, for A-levels. So first, in terms of accommodation, we're happy to accommodate our students on campus, actually. Whether it's guaranteed or not, it's a great question for the accommodation team. I believe that we are able to accommodate the majority of the students. I believe we haven't had issues with a percentage not being able to secure accommodation. Fortunately, we've been pretty good in this front. Unlike most universities in London, where this is a big challenge, but we have a lot of on-campus housing. So, but to answer that question precisely, I wouldn't say it's guaranteed, but there's a huge probability that you would secure one on campus. If students are one grade below. I would say please, so the A level is pretty critical. The minimum level is critical. You have to meet that. So if you've got the proper sort of AAA, Michael can confirm if it's AAB this year or it's still AAA, but if you have that minimum, that's what matters the most in terms of being below that minimum is not acceptable. Another science course is if that means that you're doing an undergrad in another program and you finished 1 year, then that would be a transfer question. So it's going to be a little bit tricky. And another question coming up about transfers is that can we swap between programs? It's not going to be easy, but it's not going to be impossible either. It's not something we recommend. The good thing is the first year you're all sitting in common classrooms, so the content is going to be the same. But in terms of, well, halfway through, absolutely not, because the maximum you go is first year if you really want to change program, but it's going to be very tricky. So again, if you want to do this, you want to consult the School of Engineering Materials Science and basically approach us. And if you could either send me an email or send Michael an email, and we can actually forward your question to our teaching officers.
Yeah, I can just to mention something about both of these two questions. We've had a few people asking what the standard entry is, so we can cover that very quickly now. So it's AAB for the BEng program. For those of you who might be considering the MEng program, which is an integrated master's, it's another year, an additional year. That is AAA. And it is crucial for all applicants to have a maths from their A-levels or equivalent. So for the individual who's asking about French qualifications, then we need to see the equivalent from France. And a science, that can either be physics or chemistry. With regards to transcripts, I'm presuming this is a science transcript from another university. We can do, however, our admissions team would need to know why it is that you have decided to transfer from another university. So similar to what we've already mentioned before, it's not as easy as just accepting the transcript. There will be a bit more information that our admissions team would want to know before the transcript is considered. And then there's this option of potentially transferring from mechanical engineering to biomedical engineering. In theory, I think we've already sort of covered this, but in theory, yes, you can. However, it depends on quite a number of factors. For example, how far into the course have you got so far? And also if there's actually places available, because each course has a limited number of places. And of course, we won't be able to transfer people between courses if the course they're transferring to is actually filled up. And of course, meeting the standard entry criteria to that course. Some of our programs have slightly different entry criteria. So if you were transferring to a program which has a higher entry criteria, then that obviously would be a barrier. So hopefully that's helped.
Thank you very much, Michael. I think that was pretty comprehensive. So yeah, I hope that explains all. But again, if you have further questions or you're not unsure, please do reach out. I think there's one more question here. Crossing over from BEng to MEng, I believe you have to have specified at the beginning, and again, as Michael was mentioning, there is a difference in terms of the minimum requirements. I'm not sure, is it possible, Michael, to...
I can certainly help you again. Yes, the answer actually is yes. So if you are at this stage and not sure if you want to study the MEng program, or you're in a position where actually you know you're not going to get AAA, there is a potential to join the MEng at a later date. You would need to, the current criteria is that you need to get overall 70% or above in all of your assignments and exams, etc., from your research project as well. So it is possible for students who are achieving 70% or above.
Absolutely. Wonderful. So the AAB grade requirement, foundation. Yes, I think foundation, right, Michael?
Absolutely, yes. If you don't make the AAB grade criteria, we will automatically offer you the foundation program, as long as we firstly have enough space available. So sometimes that program does fill up, but also as long as you meet the entry criteria for the foundation, which is BBB from A levels.
Absolutely. Wonderful. Any more questions?
That's quite a large question with regards to partner universities abroad. We actually have a significant number. So if you did want to consider applying to Queen Mary and doing a year abroad, I would say we would advise you at that point of which universities they are and where they are. They're actually, you know, across the world. So it's quite a significant number.
Yes, and you could probably find the list somewhere, but I think it's pretty early to decide about that. But yeah, I guess each country has a couple, so you won't. Yeah, if you're really considering abroad, you won't have a shortage there. I think BBB is the requirement, so I don't think the foundation year would be possible with a C.
Yes, unfortunately, that is correct.
Wonderful. Very happy that we had some questions. So possible to visit the campus. Yeah, absolutely. So we have open days, and we have once you've received an offer holder days and opportunities for you to visit campus. We have apart from the open days and the offer holder days, I believe that's it, right, Michael? The days that the university is open for students to visit us.
That's correct, yes. Unless you've on a organised visit with a school or your education institute, the next open day that anybody can join will be in June. Just type Queen Mary Open Day into your search browser and it will come up. I think it's June the 14th and 15th, if I remember rightly, but you can correct me if I'm wrong. It's a Friday and a Saturday. You can come on whichever day is most suited to you. If you are applying to Queen Mary this year and you are offered a place, then you will be invited to an offer holder day, which will be at the end of winter, beginning of spring, so sort of February, March time.
If it's outside the open days, unfortunately, it's going to be tricky to figure out because, the open days are those days that we plan ahead and the university doors are open. So if it's something that you really want to serve, you're thinking seriously about Queen Mary, it's a good idea to try and attend on those days. But if it does happen that, there's only a certain day that you're going to be in the UK, maybe if you contact a certain research supervisor, and again, it's a little bit too early to do this, but if you really, we have every once in a while participants who are knowledgeable in an area, they've conducted research in that, or are really interested and enthusiastic about that, they can actually reach out, and maybe the supervisor can actually help you by telling one of his or her students to give you a quick tour of their lab, maybe. But again, it's not going to be really easy. It's not going to be easy at all, actually, because to access the lab, you're going to need to have certain requirements. And so, honestly, that's why a lot of design and planning goes behind these open days and offer holder days, to give you the opportunity to take a tour and come in safely, take a tour of the labs, and then check out what's happening here.
Yeah, I think just to add to that, unfortunately, as just sort of mentioned there is a health and safety within the labs. So in fact, if it's outside of an organised open event such as the Open Day Offer Holder Day, unfortunately, you won't be able to gain access to the engineering building. And I hope. Sorry, this is slightly different information you've just received, but actually, we have quite strict rules about when people can attend. So, so therefore, if you did contact someone, the line is unfortunately that we wouldn't be able to open up the building. Yeah. That said, the location of Queen Mary at Mile End, between Stepney Green Railway Station and Mile End Station, the actual campus grounds are open. So although you can't walk into the buildings, if you happen to be in London and you'd come across from overseas and you wanted to just sort of see the location, have a walk around the campus, you can do so. It's just you won't be able to enter the buildings, and it would be difficult to be able to promise any sort of meeting with a member of staff.
Yes, I was going to add this. There are open spaces that are accessible. The campus you can come and visit, of course, but labs, yeah, unfortunately, yeah, I'm sorry to have given you that information. Again, if there were, if there were collaborations going or something, but I wouldn't just reply as a supervisor and figure out a visit if you haven't still even joined campus, the safety regulations being the main reason. So unfortunately, yeah, the open days, the offer holder days, those are going to be the only opportunities for us to do that. Thank you, Michael, for correcting that.
Not a problem. But I think one thing we should reiterate is if you can, it would be absolutely excellent if you can come to one of those events. So as I said, if you do get an offer from the university, you'll probably get a choice of 2 offer holder days. If you can make one of those, that would be really good. Otherwise, have a think about possibly visiting us in June for the open day, because I think you'll have a really fulfilling experience if you come and visit the university and meet academics and also meet some of our current students.
The foundation, so yes, if you apply for the foundation program, you can choose which engineering degree afterwards, or you don't need to have decided before the foundation has started, I believe. So I think that should be fine as long as you qualify. Will offers be received from the point sent out? Yes, the offers are all sent around a certain time. There's the one last opportunity for basically receiving an offer, clearings, and that is the only other basically chunk of applications, the big chunk that's going to receive decisions. But the main chunk, which is actually when everyone applies by deadline, you should receive responses altogether. But there are international applicants who apply a bit later and need to get through certain loops. So there can be some various dates and deadlines for receiving responses. Last question. Okay. Okay. Wonderful. No questions then. Thanks a lot. Any other questions?
I think what we'll do is we'll bring this session to a close. I can see it's getting close to a full hour. So one thing I just suddenly came into my head, sorry, about with that question with regards to when will offers be sent out. So on your UCAS, when you make an application, you'll see something called UCAS Track, also referred to as UCAS Hub, where you can see where you've applied to, and on there it will get updated with regards to if you've received an offer. Some universities might ask for additional information, and that will show up there as well. But the equal consideration deadline, so this is when applications need to be all in, and this will be slightly different to the deadline which has been mentioned to you by your school, but it's the 31st of January. So you should anticipate that in, really by the 31st of January, you should have received some information back from the university. And if you haven't, it will come very, very soon at the beginning of February, because that's when we start to wrap everything up. Otherwise, I think that's all the information I've got to say. So again, thank you for joining this webinar and spending your time with Queen Mary University of London.
Yes, thank you very much. And